Hi everyone, this is me, Seiji, and Chris's research project for 2020. So as you know, climate change and air pollution has been a very big problem, especially in the Central Valley. We're very well known for having bad air. And one possible solution to this problem that has been very popular recently is planting more trees. The reason it's so popular is because trees absorb carbon in the air. They do that through photosynthesis, where they absorb it in the soil through their roots. One area that hasn't been considered when planting new trees is agriculture areas. Just to give you an idea of the potential land, in 2012, 40% of US land is farmland. And my group believes that agroforestry is the next step to fixing this air pollution problem. So, what is agroforestry? Agroforestry is basically growing trees or shrubs with a crop to improve air quality and biodiversity. And these are just a few examples of what agroforestry looks like. So the question that we're trying to answer in our research is how many trees would you need to plant on a large family farm so that the carbon sequestration of the trees is equal to the carbon footprint of the farm? So we believe if 20% or more of the farmland is occupied by tree coverage, then the carbon sequestration will be greater than or equal to the carbon footprint of the farm.
So for our methods, we will first begin by figuring out how many trees can be planted in addition to the crops. So figure out how much land the crops themselves take up and figure out how many trees we could fit into there. From there, we'll calculate how much carbon is absorbed by both the crops and the trees. And we'll also calculate how much carbon is produced through the daily maintenance of the farm. And from there, we'll compare those two numbers to see if they're greater than, equal to, or less than each other. And so our possible results that we get from that is that we find that the trees absorb more carbon than the farm produces, allowing it to take more from the environment. The trees absorb as much carbon as the farm produces, which leads to the farm having a net zero carbon production, or the trees absorb less carbon than the farm actually produces. And some things we need to find in addition to those is what kind of tree would grow best here in the valley climate, since we're going to be doing farms here in the valley first, and the acreage of an average large farm operation. And we're thinking of using the Fresno State Farm as our main subject for this study. And so some possible limitations from our method is that most of our calculations will be estimations based off previous work due to the time it'll take for a tree to actually grow to its full potential. We can't do the research in a timely manner. And we'll also be mostly focusing on sites here in the valley for this project, and which means that some of our research will not apply to areas that have different climates from our valley. And we're also assuming that all the trees and on the farm are of the same species and size, and that also not all farms here or anywhere grow the same crop or crops.
This map right here shows just over 40 million% of all of the United States farmland, which 40% in acres is 915 million acres. And the next map right here is in 2015, and it's also the same thing. It's a graph of the farmland, but the acres are different. It's 166 million acres, and humankind, we use a big chunk of the land. And the article you see here and the global carbon cycle, as trees are growing, they help stop climate change by removing carbon dioxide from the air. If They also store carbon inside themselves and in the soil. Then they release the oxygen into the atmosphere. And these are four pictures from www.treefresno.org. And these pictures are references of what we could use to plant in our Fresno State farm, because we are talking about what planting trees on the Fresno State farm. And it just shows what we could plant. Yeah. And final, this is our references page.